Welcome to the Stormsurf video surf forecast of the week starting Sunday, March 3rd. Looking at significant wave heights for the North Pacific Ocean, we see a small area of disturbed weather, the beginnings of a gale developing north of Hawaii, generating 19-foot seas aimed mainly, we'll say, east of the island, so a little bit of sideband swell probably will radiate that way. And a portion of another gale producing 26-foot seas over the northern dateline region and really not going anywhere. And this system is pushing northeast. Not much is expected from it. But for the future, things are looking a little bit brighter. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. Looking for a trough that is a dip in the jet. We see a broad dip right there that would help support a counterclockwise flow aloft. See the arrows right there? That's the direction the wind is blowing. So think of it like a river. And in these dips, you get these eddies, and that's where low pressure can form. And low pressure, of course, generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have a somewhat consolidated jet stream flow pushing off Japan with winds in the 140, 150 knot range. Not super organized. Then the jet splits before it even reaches the dateline, the international dateline, right there at 180 west, with the northern branch of the jet pushing up into the Bering Sea, then falling south again, carving out another small little trough right there. And again, that would be supportive of low pressure development, while the rest of the jet pretty much tracks off to the east. The two portions of the jet rejoin and are pushing into central California right now. But it is that trough right there and that trough right there that hold the most interest. Let's put this into motion, see what happens. So as we get into, let's say Monday, the trough here in the northern dateline region just kind of doesn't really do much. It doesn't dig out any deeper. If anything, it lifts north and gets weaker. Kind of looks like maybe a new trough trying to dig out over the Kuril Islands. And the trough northeast of Hawaii moves off to the east. Winds not very strong. You need strong winds pushing down into the trough and through the southern portion there. That's what gets all energy pushing off to the east. This one really doesn't appear to be doing that. We'll get into Tuesday. The trough basically starts moving into the California coast Tuesday night into Wednesday. New trough starts building, though, off the Kuril Islands. The wind's a little bit more consolidated, a little bit more organized, a little bit more of almost, you see, like a wave breaking counterclockwise flow there. Maybe that's be a bit more supportive of gale development as we get into Wednesday. And more so into Wednesday night and Thursday, the trough pushes into California on Wednesday night. Another one following behind that as we get into Thursday, Friday. And then you see 1, 2, 3 little troughs. This all looks like a train of weather pushing to California, where elsewhere out here back in the West Pacific, another trough tries to develop, not very organized. So we're into the weekend now, and the jet is pushing off of Japan. No troughs. Almost looks like it wants to split here about midway to the dateline, but it doesn't. Pulls back together into the dateline, but the whole jet is pushing off to the northeast. And what remains of this split flow, kind of get this backdoor trough thing building off the Pacific Northwest. That typically pulls cold air from Alaska out over the ocean inland. So that would be good maybe perhaps for a light, good quality snow development in this region. We'll see what that does here in the next couple of frames. We get into Sunday night, a week out. Yes, that continues to dribble into, let's say, Northern California, Oregon area. Something to watch, but the jet just looks really fragmented, not particularly well organized, and not particularly supportive of gale development. So we have a couple of troughs back here, let's say midweek or so, 2 troughs of semi-interest, and that's about it. Let's go take a look down at the surface and see what effects the jet stream will have there. So here we go, surface level pressure, surface level winds, and as expected, a little weak low pressure, what is that, 10 millibars northeast of Hawaii, barely producing 30-knot winds, maybe good for some wind swell production for the islands. Then a broader trough with up to 40-knot winds, but for the most part, all of it north of the Aleutian Islands, offering no real hope for gale development. So we get into Monday, that same sort of pattern continues. But then as we get into Tuesday, a decently organized gale starts developing, 45-knot north-northwest winds aimed somewhat Hawaii, taking shape. Also, this weak little low continues pushing towards California, looking more like a weather producer than any sort of a swell producer. We'll continue on. There we go. Into Thursday afternoon, Thursday evening, decent-sized fetch of 45-knot winds, targeting the islands and the U.S. West Coast. Weak low pressure, what is that? 10,000 or 10,004 millibar low. That's not much of a low. Good for rain, that's about it. Not even hardly any wind relative to the U.S. West Coast. All right, so let's keep our eyes on the prize here. And then we get into Wednesday morning, 50, almost 55-knot winds. This looks like it could produce some swell. Rather north angle, and most of it pushing off to the east, so sort of sideband swell relative to Hawaii. More direct fetch aimed at the U.S. West Coast, maybe up into British Columbia. And 55-knot winds, officially a storm midday Wednesday, if you believe that, continuing into Wednesday night, and then starting to fade out on Thursday with 45-knot winds over the northern dateline region. So right around here, you see this, it's about 305, 306 degrees relative to Northern California. More for Southern California, less up into the Pacific Northwest. And it starts fading out. New system starts building behind it, though, with a small area of 45-knot winds on Friday, building to 50-knot winds on Friday night, taking pretty much the same path, 50-knot winds into almost Saturday, backs off 45-knot winds. Now, these winds aren't aimed directly east. They're almost aimed east-northeast, but still swell, spraying probably into this whole area. And then it, too, fading out. Still fetch as we get into Sunday, 35-knot fetch in the northern Gulf. And then it's gone. Oops. And there we are at the end of the model. High pressure ruling supreme at 1032 millibars, filling the central Pacific. And, you know, when you get that sort of a strong high pressure on the south side, you get a lot of easterly fetch relative to Hawaii. So that means strong trades for the Hawaiian Islands and, you know, not a whole lot else going on. All right, so let's take a look at the effect of those winds on the ocean surface. What's that do in terms of producing seas or swell? So we'll go back. Here we go. There's that little area of 18-foot seas associated with low pressure there, aimed somewhat at Hawaii. We're really not getting too interested in that. Nothing else going on until we get into like Tuesday afternoon. There's the storm, we'll call it storm number 1, developing 30-foot seas, spraying pretty much this whole area out into here. Not so bad. Building into Wednesday. And then as we get into Wednesday night, what is that? 46-foot seas, 46.8 to be precise. Foot seas just south of the Aleutians in the northern dateline region, aimed east. So the main target, probably somewhere from Point Conception up into the mid-Canadian coast. Building to 49 feet. It's a little bit of an upgrade. Then fading on Thursday and pretty much gone by early Friday. Still, solid swell. Should be radiating out from there. Second system building in behind that. And not quite as strong as it was forecast earlier today. Still 43-foot seas projected, making it into the western Gulf and then fading out. And then that's pretty much it. And so let's do a quick look at the propagation of those swells. Remember, there's a system here. So this chart, we haven't ever done this before, but this is the integration of swell height and swell period, like here, right under the fetch, and here, right under the fetch. You don't have any swell, so it just kind of like it evaporates. But you'll see as we move in time and seas start maturing into pure swell, then you get, so this is the theoretical calculated surf height if there were land in this area. So theoretically, what's that? 10-foot surf pushing, but most of it east of Hawaii. So the fragment you can see there is about 7 or 8 foot surf. Then some swell out here associated with low pressure, but it's just convoluted. Here comes the system that really matters on Wednesday, and you can see lots of contours here, somewhere well above 40-foot surf, but that's for the Aleutian Islands, raw, stormy conditions. It's more as you move away, and here you go. Then you can see the core of the swell here, 38-foot surf in this location. Of course, no land there. And then the next system building behind on Friday night. So here we go. We're moving. Oops, we'll actually pull this back. So there's Hawaii right there. You can see, what is that, about 13, 14-foot waves pushing into Hawaii on Saturday night, and then into the U.S. West Coast on Sunday. This is all calculated now, remember, and that is, about 15-foot or so, if one is to believe the model and all that kind of stuff. That's 180 hours out, maybe. Yeah, about 14, 15 foot, something like that. And another system building behind. So at least this way, you get a sense of when the swells are going to arrive, roughly how big they are. And you can look at this one chart and pretty much that gives you a sense of what you need to know. It doesn't talk about really swell direction, swell shadows, so it kind of hints at it. It doesn't tell you what the local winds are going to be, but you get the general idea here. All right, and let's take a look at the wind forecast here for Hawaii and the U.S. West Coast. Of course, here we are Sunday. Looks like east-northeast trades for the Hawaiian Islands, kind of a mixed light onshore wind pattern for California. As we get into Monday, more of a northeast trade, 15 knots for Hawaii, and northwest winds will say 10 knots for California, north of Point Conception. And as we get into Tuesday, more of the same sort of thing. East-northeast trades, 15 knots. South winds building for California as the front from this low approaches the coast. And building south winds, 20, 25, almost 30 knots for the Central California coast. Tuesday night, trades continuing for Hawaii. Wednesday, more south winds, 20 knots for California, turning northwest, 20 knots. More trades for Hawaii, up to 20 knot range. Thursday, winds slackening as another low builds off the California coast, this time falling south towards South California. There we go. And a northeast flow by Friday, perhaps for Northern California, at least for a little bit in, we'll say maybe midday kind of thing, but probably a pretty jumbled sea state. Strong trades. Here's your high pressure, 1034 millibar on Friday night, building for the Hawaiians at 20 plus knots. And as we get into Saturday, light flow along the California coast, strong trades for Hawaii again, and that continues. Then we get into Sunday, maybe a east-southeast flow for Central California, something like that, turning more southerly as the day progresses, and strong trades again in control for the Hawaiian Islands, and that's the end of the week-long run of the model. Let's go take a look at precipitation. And we're focused mainly on California here. You see rain along the coast as of Sunday evening, snow mainly for the Tahoe region. Roll this out. No precip on Monday for California, but here comes the next low. You see the rain building up off the coast. By Tuesday, mid-morning, 18Z, that's about 10 a.m. in the morning, Central California starting to get rain. See a pretty good plume focused right in there on, we'll say, the Big Sur area. Continuing pretty solid rain and snow in the higher elevations of the Sierra, except down here towards Mammoth, a pretty good chunk of snow there for a short period of time. More rain on Wednesday, snow for the higher elevations of the Sierra, then fading out. Still snow for the Sierra on Thursday. Scattered showers. When you see this sort of thing, it's just scattered showers for Central California and Southern California. That starts fading out Friday. The next system pushes into Southern California. Light rain there. Light snow showers for the Sierra. Then a break on Saturday into Sunday as the next system starts winding up off the coast, and maybe by Sunday evening, rain starts building in for all of California and probably through Sunday night. So again, sort of this couple days of rain, it backs off, maybe a day of clearing, then another couple days of rain, and it just keeps going and going. I mean, this is great for building up snow pack in the higher elevations, Sierra, filling up the aquifer in the Sacramento area, central part of the state, and keeping things nice and moist along the coast. All right, let's take a look long term. What's going on with the Madden-Julian Oscillation, the MJO, and of course the El Nino Southern Oscillation. As usual, we start by looking at winds on the equator. So it's just the arrows here. The colored and the contours are water temperatures. We're not so much interested in that initially. We're looking for presence of the active or inactive phase of the MJO. And we see, so this data from the TAO buoy array, series of buoys strung across the equator. This is the equator here, 0 degrees. New Guinea, off in the far West Pacific here. This is the East Pacific here, well, somewhere south of Mexico. And you see winds are from the east across the entirety of the Pacific, even in the Kelvin wave generation area. This area from 5 north to 5 south, from about 135 east to 170 west right in here. When you get west anomalies in here or west winds, that's a good sign of the active phase of the MJO. And if those winds persist for months on end, that's a sure sign of El Nino. All right, so what we're interested in anomalies, differences from normal for this time of year. And looking, you see, well, yeah, there's a little bit of easterly anomalies here in the East Pacific, a little bit of westerly anomalies in the West Pacific. But in the Kelvin wave generation area, right over in here, weak east anomalies. So one would say probably a weak inactive phase of the MJO is in control. That's per this data. Let's keep digging. What have the winds been doing for the past 5 days? Okay, well, 850 millibar vector wind anomalies. So basically the same thing, just a bigger scale chart here. There's South America, there's Mexico, New Guinea, Philippines, Kelvin wave generation area. That's the box we're interested in. Draw this in your mind, right from there to there. We're looking for westerly anomalies, which would be like the arrows coming out of the west and the red and orange boxes. So we see, yes, on February 25th, yeah, westerly anomalies in the Kelvin wave generation area, continuing through the 26th, 27th, but progressively getting smaller, covering less area as we went through the 1st of March. Let's go take a look at the forecast. So this is a little bit different chart. This is, again, 850 millibar zonal wind anomalies, but for the whole planet, right? So the date lines here, the Pacific, the West Pacific, start right about here and goes to about here, 90 west or so. But the Kelvin wave generation area between these two tick marks. So you can literally, and this is past history from February 1st through the forecast, and we'll see. The reds and oranges and purples are westerly anomalies. So if this is the Kelvin wave generation area here, you can see we've had nonstop westerly anomalies in the Kelvin wave generation area, and pretty strong indeed. In fact, a full-on westerly wind burst from the time period February 11th through February 28th, and that would be indicative of the active phase of the MJO. But then you see starting about February 26th, on about February 28th, the blues started building in the Kelvin wave generation area between these two tick marks. That's indicative of the inactive phase of the MJO, easterly anomalies. And that, so here's today's date, that's supposed to continue for another 1, 2, 3, maybe 4 days. And then the inactive phase of the MJO, or at least the easterly anomalies associated with it, pretty much die out. You just get a neutral wind pattern. So if this is an inactive phase of the MJO and it only lasts for, I don't know, a week or something like that, and we've had literally weeks prior to that of westerly anomalies, that's suggestive that, if anything, the Pacific is biased towards westerly anomalies, which would say it's biased towards some sort of a weak El Nino-like pattern, and that is good news. We can also look at these Madden-Julian Oscillation forecast charts. This is outgoing long wave radiation, another way of saying cloudiness. You know, the blues here negative anomalies, meaning more clouds. That's probably where the active phase of the MJO is, in the Indian Ocean. The reds, more sunlight reflectivity off the ocean's surface, meaning the inactive phase of the MJO. And this is the statistic model output. It goes for 15 days, 2 weeks roughly. And it suggests that the inactive phase is to last for a week and a half, and then die with the active phase of the MJO building in the far west Pacific. That would be great. Unfortunately, the dynamic model, the GEFS model, suggests the inactive phase is basically to hold steady and, weaken, but not give up any ground, with the active phase stuck in the Indian Ocean, making no headway into the West Pacific. So that's a less favorable projection. The two models are at odds with each other, and we don't know which one's going to win. Phase diagram charts, another way to look at the same thing. How to read this chart: assume you're looking down on the North Pole, and the MJO, both active and inactive phase, move from west to east, from the Indian Ocean over the maritime continent, through the West Pacific, across the rest of the Pacific, under the United States, across the Atlantic, into North Africa, back to the Indian Ocean. Heavy dot is where the active phase is today, right square dead center in the Indian Ocean. The further away from the circle it is the stronger it is. So, moderate strength link safe. If it's out here, it'd be very strong. This is the statistic model. 3 different branches of it suggest that the active phase is to move basically over the maritime continent, maybe very weak, maybe moderately strong, 2 weeks out. The GEFS model saying active phase, same place, but making about 4 days worth of headway, then weakening, crashing, and remaining very weak, which would put the inactive phase probably on the exact opposite half of the planet, somewhere in the West Pacific. So that's not particularly good news. The upper level model, again, okay, so this is, let's see, there's South America, there's Central America, there's New Guinea, Kelvin wave generation area right around in here. We want to see the active phase in the Kelvin wave generation area, because when it's there, it imparts energy to the jet stream. That helps get rid of the splits in the jet stream, and it also helps support, of course, Kelvin wave development. That's why I call it the Kelvin wave generation area, because when you have the active phase here and it produces west anomalies, and especially westerly wind bursts, that creates Kelvin waves, and that's a component of building El Nino. All right, so the oranges are areas not favorable for precipitation, so one could interpret that to mean the inactive phase, the MJO. It's pretty much in control of the entire Pacific today. Slowly is to move into Central America through about March 18th or so, while a weak version of the active phase, this sounds like it's a statistic model sort of output here, starts building in the West Pacific on March 18th, making its way across the Pacific through about the 7th of April, and then a stronger inactive phase builds, let's say the first week of April, and makes its way to the Central Pacific at the end of the model run about mid-April. And yet one more model, CFS model. This is the 1 month version of that model. Here we go. This is one of those charts again, whole globe on one chart. Kelvin wave generation area between these two tick marks going up. The dotted contour is the inactive phase of the MJO, but you can see here this goes back to December. The reds are westerly anomalies, and you can just see in the Kelvin wave generation area between these two tick marks it's going down. It's been almost continuous active phase of the MJO. That's a clear sign of something that smells very much like El Nino. So here we are today. The dotted contour is the inactive phase of the MJO, and a little bit of blue here. So this is our supposed inactive phase of the MJO. Each one of these tick marks is 1 week long. A week from now, inactive phase is supposed to be dead. We get back to these oranges, westerly anomalies. Here comes the building active phase of the MJO about mid-March. And from then on, we're in business, supposedly. And then here's our favorite view, the long 3-month view. This is reversed. Past history on the bottom. Here's the Kelvin wave generation area. Westerly anomalies, the oranges and yellows. And you just see as you get here, here's that strong run from about mid-January up to about a week ago or so, westerly wind burst. And look at the forecast. Very interesting. Much more strong westerly anomalies at westerly wind burst status for pretty much the entire forecast period as compared to what actually happened back from November into present. This almost smells like if there's some sort of El Nino thing, it's only going to be getting stronger, not weaker. Just eyeballing it like this. We'll overlay the MJO. The dotted contour, here's our inactive phase of the MJO, goes from now in the Kelvin wave generation area into about the first week and a half of March. But even at that, westerly anomalies building. Here's the solid contour active phase of the MJO taking control. Strong westerly anomalies from, we'll say, starting mid-March to mid-April, even with the inactive phase. Beyond that into mid-May, and then mellowing out a little bit. If this materialized, this would be an epic run of westerly anomalies, and definitely indicative of a building El Nino situation. Typically in the February-March time frame, if you're going to have a solid El Nino, you can start seeing good solid signs of it. This is sort of hinting at that. We'll overlay the low-pass filter here, and makes perfect sense per this model. So this is the we'll call it the low pressure bias. They call it the low pass filter, but it says you see solid contours in the Kelvin wave generation area centered over the dateline like this. That suggests, well, here we go, sort of a building low pressure bias, which is the hallmark of El Nino in this region. We were at 3 contours, but then it faded in December. I think part of what's pulling the jet stream apart and all this sort of weak jet stream thing that's been going on since pretty much January is this: we were in a building mode towards El Nino, then it sort of fell apart, and now starting in February we're starting to rebuild, but it takes a while for the atmosphere to respond. Notice this, as we get into April, we're supposed to go to 4 contours. That would be a maybe yet another sign of a building El Nino situation for the fall of next year. Maybe, just maybe. Anyway, so that's sort of what it looks like per this model. Things are looking hopeful. So what's going on subsurface? This is the ocean. West Pacific here, East Pacific here. These are the anchor lines, and the X's are the actual sensors on the TAO buoys strung across the equatorial Pacific. From the data from this, with a little bit of modeling, you can sort of fill in the gaps, get an idea of what the balance of water temperatures are across the Pacific. Warm water in the west at, 29 degrees Celsius. 28-degree isotherm, about where it was last time we reported was at Friday or Thursday, Friday a week ago. At 161 west, and the 24-degree isotherm moving into Ecuador pretty much unchanged. It's anomalies, though. Differences from normal for this time of year. That paints the real picture. And you can see here, what is this? A 4 degree centigrade pool of warm water under, about down 150 meters, under basically an area south of Hawaii, we'll say. Okay, and stretching from west of the dateline almost to 110 west, that'd be south of California, or more so, almost into Baja. So this is typically what one would say is a Kelvin wave. Remember, we had all those strong westerly anomalies in February. There's actually westerly anomalies that went on for months in this area associated with active phase of the MJO. It has taken warm water, some of this warm water that's here in the West Pacific, and starting to push it to the east in the form of, this is what, Kelvin wave number 3. It's actually a combo, Kelvin wave number 3 and 4 mashed together. This will take 2.5 to 3 months to make it into the Central American coast and then erupt on the surface there, creating potentially a warm slick on the ocean surface, helping to feed El Nino development. That's good news because we already know there's a fair amount of warm water building up here on the equator, and with this coming in behind it, that will only add fuel to the fire, and hopefully the atmosphere will respond in kind. Another different modeled version using the same data, and we see 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We'll say 4 to maybe 5 degree above normal anomalies. Basically, this is a river of warm water pushing off to the east. Here's the last upwelling phase of the Kelvin wave cycle, little cool pocket. That's going to get wiped out here in the next couple of weeks as warm water moves in and takes over for the next couple of months. More confirmation of that, this sea level anomalies. So there's Central America, South America, New Guinea there. Here's the equator. There's the date line. This is from JSON 2, JSON 3 satellite data. Strip out all the wind waves, strip out the swell, strip out the tides. And what you have, you see a bump, a 5 centimeter bump on the ocean surface, or 0 to 5 centimeters, filling this entire area. If you have warm water at depth, it expands, right? And it creates a little bump on the ocean surface. And all this is doing is confirming what we saw in the other charts. Just you use multiple sources to confirm that all of them are sort of in line. And this sort of suggests that is in fact the case. Warm water under the equator pushing off to the east. And then our historical look chart. West Pacific here, East Pacific here. This is time. Last year in the April time frame, this was Kelvin wave number 2, really, I believe it was. Actually, we'll say Kelvin wave number 1, the first real one, pushed across the ocean from, what is that, March time frame into June, July, okay, warm water, you see. Then upwelling phase of the Kelvin wave cycle, there's that little cool bubble, right? Then much larger Kelvin wave number 2, pushing from west-east, associated with westerly wind burst and westerly anomalies from, we'll say, September into the December time frame. Then here's our upwelling phase of the Kelvin wave cycle, our little cool bubble. Here's Kelvin wave number 3/4 building and looking pretty solid indeed. We'll see how it materializes, but it's got another 2 months before it erupts along the coast here, maybe in the April-May time frame, something like that. So sort of smells like some sort of El Nino is trying to develop, but it hasn't yet. Not completely. Yeah, NOAA's saying it is, but it's so weak. You know, we're not seeing it in the jet stream. We're not seeing it in the storm track. We are seeing it in terms of swell generation. We're not seeing it. In terms of precipitation into California, doing quite well indeed, with 200-inch snowpack in Northern California Sierras, and quite a lot. I think I saw some charts that suggested maybe the 3rd or 4th wettest winter in Northern California in the past 50-plus years, something like that. So, indeed, sort of smells like El Nino, even though it's not really suggesting that from a surf perspective. So we've talked MJO, we've talked westerly wind burst, we've talked subsurface ocean temperatures. How about at the surface? What's going on there? Well, we actually have some good news here. Warm water along Peru, that's a hallmark of El Nino. And down into Chile a little bit, this little cool finger off Colombia persists. We were hoping that would be gone. But the interesting point this week is warm water building on the equator. This is the best it's looked since, the fall or something like that. And kind of in an El Nino-like configuration. There's been this pocket of cool water hanging right around here for, it's really remnants of La Nina. That finally seems to be washed out. There's really no cool water to speak of anywhere north of 20 south. And you get that kind of triangle-shaped pattern starting to set up here. If it's like this now, and if westerly anomalies persist and blah, 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 we could have a real El Nino by next fall. So we'll see whether this is a temporary pattern or something that is going to continue to develop over the coming months. We're in what they call the spring unpredictability barrier, that time frame from February to about the end of May. The models have a real hard time telling what's going on, but you know what? Sometimes you can just sort of watch the ocean and see for yourself, and as of right now, things look fairly positive. The trend here for the past 7 days, and a 7-day trend is not much of a trend, but suggests warming off of Peru, all along the equator, other than that little finger of cool water between, we'll say, what is that, Panama and the Galapagos. But generalized warming, and all down here, this is where that cool pool had been. Looks like it's finally gone. So at least things are moving in the right direction. And then the overview picture, again, here's that kind of triangle of warming looking suspiciously like El Nino. We're actually past when the peak of El Nino normally peaks in the late December, January time frame, and here we are into March, and temperatures are actually building, not getting cooler, And typically you would expect to see cooling and decreasing temperatures here if El Nino was collapsing, and it doesn't appear to be doing that at the moment, but we're not going to get ourselves too excited just yet. We have a long way to go till next December. The temperature trend in the Nino 1.2 area, that's the area just tucked up there along Peru and the Galapagos, is actually, you can see today's temperature is neutral, 0.060 above normal. And if you look at this, the trend, if you draw a line through it, has been steadily downward here off of, in the Nino 1.2 region. But in the Nino 3.4 region, that's the official El Nino monitoring region. It's on the equator from basically south of California out to the date line. The trend has been pretty much flatlined, if not slightly going down. But as of late, 1.189 degrees above normal. This is the highest it's been, I think, at any point this year, and the highest it's been in several years. But again, it's only for 1, 2, 3, 4, 5 days. That is not a trend. We got to see how this sort of averages out over the next couple of months. El Nino is 5 months of half a degree anomalies or better. Yeah, we have that. But the atmospheric component, yeah, it's there from a rain perspective, but not from a surf perspective. But in some cases, we'll take the rain and the snow. We need it, so it's not bad. So let's talk about the atmosphere. Is the atmosphere responding to the warming in the ocean and the Kelvin waves and the active phases, the MJO and westerly wind bursts and all that sort of thing? So, Southern Oscillation Index, difference in pressure between Darwin, Australia and Tahiti. When this is the 30-day average, when it is going down, when it is negative, and you see it is down at like minus 14 today, that's a sign of the active phase of the MJO. The 90-day average, which is graphed here, you see here's 0. It needs to go way negative before you have El Nino. We're at minus 2.53 today. So that's not really negative. That's basically hovering around neutral. Here's the actual data. You can look at it. Daily contribution for today, minus 5.22. But here's your 30-day average, minus 14. See how we were down at minus 43.61 on February 19th. So you can sort of eyeball this thing. It was basically neutral, then just dove with that big westerly wind burst, the active phase, the MJO, and now it's sort of fading. The 30-day average responded in kind from basically neutral, dropping down to 14, but the 90-day average had been hovering neutral. This is why we said, yeah, NOAA said we were in El Nino, but looking at the Southern Oscillation Index, not really. I mean, we're just neutral, and we're still at minus 2.53. This guy needs to be down around 10 or something like that before we're going to say we're in El Nino. We have quite a ways to go there. So here's the 30-day moving Southern Oscillation Index over the past 2 years or so. You can see back in 2017, we were just coming out of El Nino when the numbers were positive here in the latter part of 2017 and 2018. That was La Nina. Then La Nina pretty much is dead, and you see us falling deep on the chart now. But this is basically every one of these downward pushes, like there, and here. That's all the active phase of the MJO. As soon as the inactive phase passes, or as soon as the inactive phase sets up, we expect these numbers to start rising up towards neutral. But if we're lucky and we're in some sort of El Nino, maybe they'll only make it up to minus 5. Guess we'll see. Then the other index is the ESPI index. Instead of the difference in pressure between the area north of Darwin, Australia and Tahiti, it's the difference in precipitation. When you're dry here, wetter than normal here, the index goes positive. Today we're at 0.98. So maybe, was that 1 standard deviation above normal in this area, which is right here. So that's a good thing. This is the highest we've been in 3 years, something like that. So it's still not really El Nino-ish. I mean, we're not seeing a significant amount of precipitation in this area, but we're definitely moving in the right direction. This is, again, the highest it's been in 3 years. So, and all this past winter, it's been right hovering around just neutral. So this is when we say El Nino, not really. I mean, this index hasn't showed it. The Southern Oscillation Index hasn't shown it. The surf pattern hasn't really shown it. The only thing that really has shown is precipitation into California, but we'll take anything we can get. The official forecast from the CFS version 2 model for the Nino 3.4 region, that's sea surface temperatures. Today, we're about 3/4 of a degree above normal. That's definitely El Nino. Anything half a degree above normal for 5 months. So that we're about there for that threshold. And this model, completely off the charts, suggesting temperatures climbing to 1.75 degrees above normal as we get into October. That's pretty out there. That would be like bordering on near strong El Nino territory by the fall. We're not going to buy into the hype yet. Let's show you something else. So here is the sum of every model on the planet, dynamic models, statistic models. You can see the average numbers of the heavy green and blue lines here. And so where are we? This is January, February. Here's where we are today, and each of the models making their prospective claims on where we're going to be. But you can sort of see, we can look at all the details here. I'm just going to go to the average of all the dynamic models, and this is from February out to October. Today, 3/4 of a degree above normal. By the fall, 0.36 above normal. The statistic models hovering at about half a degree above normal. And you go, well, that isn't very good. That's not like what the CFS model said. But you know what? It actually is. I would much rather see just this steady half a degree to 3/4 of a degree above normal temperature go on for 3 or 4 years without ever making El Nino grade, because what it'll do, it'll still just get the piles of momentum building in the atmosphere. The jet stream will wake up and it'll respond, but you don't get this, the hyperbolic, one extreme El Nino to La Nina sort of crash thing, sort of a bipolar pattern. Instead, you just get this steady kind of slow momentum building, storm after storm, and that continues through the summer and goes for a couple of years. To me, that's more worthwhile than a 1-year big El Nino and then crashing and suffering 2 or 3 years of La Nina and having to recover from all that. So we'll see where we're going. So all the models are all kind of mixed up in many different ways. No one knows where we're going. We're in the spring unpredictability barrier. No big surprise. But my general sense is some sort of slow building warming pattern is probably where we're headed. So to wrap things up, 2 storms forecast for the northern dateline region this week. Swell arriving by the weekend. Nothing huge, but surf nonetheless. We'll take it. Any waves are better than no waves at all. And consistent rain pushing into California. Snow levels a little bit high in the Sierra. By the way, we're still working on getting all the models up to speed. We've been playing with it, trying to work some bugs out. We've got the GFS, all the GFS stuff pretty much working now. We've got the short-range 3-hour wind forecast for along the U.S. coast working, and we'll be working into getting the Hawaii, the 1-hour NOM models up, and the Hawaii wind models up, and then eventually into the snow model charts. We might actually go snow model charts first, and then go into the deep dive 1-hour high-res wind models after that. Either way, we got a way to make all this stuff happen, and we're recovering from the change that NOAA set up. No big deal, though. We will manage. All right, and so long-term, yes, MJO in the inactive state right now. It'll come out of it. Forecast looking extremely favorable for about 3 weeks out from now and continuing for the foreseeable future if you buy into the hype from the CFS model. But we'll go with 50% of that, which still isn't bad. I mean, so basic, that means continued some sort of swell production pattern. There was even, we didn't look at it, there's even hints of maybe some southern hemi swell building, a storm building 4 or 5 days out from now. If that materializes, we'll talk about it on the website and the forecast and maybe next week. So, and long term, maybe not El Nino, or maybe just a low-grade gurgling El Nino for the foreseeable future. That is great news. I think we've rounded the corner. We're in a good place. Anyway, that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.